Okay, we will continue now. So what we're going to do is, the microphone is too far. I gave it a little break and I forgot. Okay. So we did finish the second resist particles and instances. We didn't finish the instancing part. We didn't put any geometry on them, but they're kind of like behaving as they should. In the landscape secondaries, we're going to branch out to the right side. We're going to use as much as possible from this web resource. And we're going to use them as, the neighbor was screaming, as a pyro simulation. So let me have a look in my old section a little bit here. So I already have these. So let's enable. Remember this guy we had for testing. Let's enable that. So it's kind of like a lot faster than it should. For our testing purposes, let's load it in. It's here. This is also here, but I don't see anything. Why? What's going on? This was just working. Hello. Oh no, it's pinned. Maybe it's looking inside the simulation. Nope. Here. No, it's not visible. Where's my geometry? It's here. Okay. We're clipping. Oh, good. I said okay because not loading the points. Oh, it is. Oh yes, because this was working on a different area. So maybe if we go here, because the wedge value changed, so it kind of lost the visibility from before. But I want a very similar area anyway, somewhere in the middle, somewhere something like this and this. So if I look here now, yeah, that should do. Okay, so if I look here, scrub. All right, that should do. So again, this is going to be our collider. This is fine, but this time we're going to use the Pyro Solver. Okay, and we can even try using the minimal solver, but that's going to be not advisable in a studio environment unless you have the GPUs available on the farm. However, if you do, it's not like this one. Where is it? Sourcing, solving, advanced. You can turn this on and it should work. So we're going to convert these guys to our source. Let's do something like this so it's kind of clean, because we're going to do additional work on those geometry, so we're going to need some space. So let's call it in source point. So points, I named them as PTC. Going to create a little random attribute here, randomize for the velocities. Okay, so for now let's give it a go for 20. Let me turn this off for now. 20, and it's going to be a Gaussian just to randomize the points. Let's focus back on the geometry so we know where this is. So yeah, I'm going to turn this like this. So this is a nice angle to work with. And if I go here, this should be still fairly fast enough. Yeah, we can always do this. Do a little caching here. And let's say cache for the next, I don't know, 100 frames. And if I do that, it will keep that until 100. So then up to 100 is going to be a lot easier to work with. So now pay attention that it's generating a lot of points because we are on a test region. So usually I bring down the amount by another digit. Let's keep going. Okay, so if I go back now, here I can press play, and it didn't actually. Well, it didn't cache it. Doesn't matter. Okay, we'll skip it. So velocity, it's gonna give us a random of 20. This is the smoke. Now let's create a pyro source. Pyro source. Plug it in here. So we want, what do we have here? We have mass, so we can link the mass to density, I guess. So we can say density. Actually, we don't have to because we already have that. And we already have the noise, so we just need to rasterize these things actually. Rasterize attribute, volume rasterize attributes. So if I plug it in here, because Pyrosource just creates these, and then you can go like initialize, like I want to create smoke. So it's going to tell you need density and temperature. But we already had those values. So it's this is going to create the point attributes there because temperature. But we already have our attributes. So we can say, I want to use mass. Okay. But it creates a mass, right? So we don't want that. You can say attribute. Can we rename them? I think you can even rename them in the sources, to be honest. Source, yeah, we can say my mass is my density, and then you can say my temperature is my, we're gonna say it's the same, my mass is my temperature. We're not gonna make any explosions, but we can drive the heat to drive the turbulence. If needed, we can make explosions, and my mass is my flame. That's pretty much my velocity. My V is my valve, which we have here, but we're gonna need to do that as well. So mass and V basically, and then I should be able to just plug this in here. Since this is sparse, I think it's just gonna work, but because our size is so big, let's start safe. Let's go 5 and let's press play. Let's see what happens. Obviously 5 is too much. Okay, let's go 1, press play. It's emitting some stuff. We don't have colliders at the moment, don't forget. Let's maybe visualize by density so we can see it a bit better. And we can also do it here. Look, this section. And we don't want emission. We want to take advantage of it, maybe in our sim, but we don't want it to do anything. Okay, density. Let's keep pressing. So we want some negative fall. So eventually I didn't use the sparse solver. I don't know why. It would have been easier. Well, I used the sparse, but I didn't use the Pyro Solver. So let's call it. But this is the way I want actually this to go. We are gonna bring on our collision. Obviously, object merge in call. Okay. By the way, let's save this. So at the end of the last lesson, I saved as 03 landscape secondaries part 1. Now there's going to be 04 secondaries part 2, which is the VDB part. Save. Okay. In collision, so what's gonna come here now is source. Where's our VDB here? Okay, here, and we can plug this guy here. But now we need to tell it that what's coming in is not a geo, it's a STF. And here we should probably name this guy collision. And this one, collision well. Now the V becomes collision well. So if I have a look here, I should have, oh, where's my velocity? Point V, sorry, yes. So now this should create me 2 fields, and STF volume velocity does understand that, but let's find out actually to understand how this works a bit better. So which switch is this? Switch if this is connected to minimal solve, this is connected to also minimal solve. Pyro post process, this is connected to minimal solver. Where is my collider? This is if it's a geo, and this should be, oops, oh, no, go back. There should be a part that says collision source. There you go. It's looking for here, you guys can see. So like if we mess this up, it won't understand. So it's gonna find actually the V. So see, like previously we would pipe this in as collision well. Now in this Pyro Solver, it's actually source volume is expected name is V, right? And it's changing it to collision well. So we need to now fix our point collision well to V. So now we have a V as a field, and Pyro Solver will understand that it's a collision field. If you press play now, it should emit less, basically from because from all the gaps that we had before. And okay, let me just go down here. Okay, I do want to take advantage of this minimal solve. So let me give that a go. See how that works. For this to work, you need to define the max size, I believe, and that will come from, you can bring in the collision geometry and then say, I guess, put a box, right? And then we can say maybe twice the size of this. Okay, so then it will be centroid. Let's do something like this, just for the test. Null. We don't want this to update every frame. Time shift, and we know that these things go down, so kind of like, let's break that up and then say, you know, go down a bit more. So I know, let's say 1050. It's already not that fallen down. Let's go 1100. Okay, so it's a bit more down, you know, let's go 1150. Okay, I don't want it to get bigger than this, so you know, that's my size. Out max BB, and then here we can say centroid, give the address to out max BB, and this is dx, copy paste dy, copy paste dz. Now we need to get the max size. Max size is not centroid, it's BB box. Same object, however, right? It's out max BB, comma. Now it's going to tell us, oops, sorry, close quote, comma. It's going to tell us dx size, d underscore x size, close parentheses, copy, tab, paste, y size, and z size. Okay, so then it's kind of going to know how big it can get max, right? And it's open on all sides. Okay, I'm just gonna save this in case it crashes or something. It shouldn't. I have a beefy video card. Let's turn that on. I believe the sparse needs to be off for this to work. Let's do a little test on an empty Houdini scene, so it doesn't explode on our faces. Frames before solve, I think this needs to be turned on to a certain frame number. Let me press play, see what happens. And it's not throwing out. Okay, oh, it died because it doesn't, because there's a source value that's supposed to be fetching to a certain frame number. Let's find that out, because this is I'd like to know. I think it's called minimal. No, in maybe geo. Dive inside minimal. No, GPU. Yeah, Pyro configure GPU explosion. I think it's this one. It brings in all the stuff. And then here in the sourcing, oh, it has these things, cycle length, sourcing. So maybe we should bring that guy in there. Do we have that in our sourcing? We do. Okay. So I want to, because I think this turns on when you turn the minimal on. Yes, you see, because it kind of like pre-sources it, I think, to puts in the memory. I don't know, to make it faster. And what about the sparse? Is the sparse off? Advanced sparsity is on, but it's turned off, I guess. But let's keep it as it was. All right, so then I'm gonna turn this off. This is on, and then turn this back on. Now go to source, and I want to source this now actually for until the end of this frame, 150. So it might take a little while to cook. 1150, and I think it's gonna then do it. And it's doing it now. Gonna pause. I think it's gonna help us to iterate much faster. So I'm gonna actually wait because it's cooking the debris source at the moment. Okay, I did like 50 frames, but it's not really telling anything. It needs to be, I think, pre-cached. Maybe it works better with explosions. I don't know. I'm just gonna turn it off, honestly. Turn this off and use OpenCL and on. And it died. Why? Because it says sparse is not supported with OpenCL. Let's turn this off. Go back to the first frame. So this should kind of like fall down now. I'm getting little messages, sorry, on my simple screen recorder. Are we skipping frames? Hopefully not. Maybe the GPU got the audio a little upset. It's very possible. Let's ignore it for now. Let me think. So I'm going to, what is slowing me down is the collision, right? So let's turn this off for now. I'm going to bring in the settings from my other Pyro Solver. So in the time scale, I changed my time scale actually to 0.75. So these are my working numbers. So I guess we can always play with these, you know, that's why we have wedging systems. They might come really handy. You know, change the turbulence, see how it feels, see how it works. Hopefully it's gonna help. Okay, temperature 0 to 1, roughness 0.7, turbulence 4, turbulence settings, serial size 4, 0.7, 3, density, this is all same. Advanced is sparsity is turned on. That's pretty much it. I'm gonna save. Let's see if anything's gonna explode really. So, and then plus of course the collision needs to be plugged in, and then my resolution was at 0.5, right? I think we were now at what, 2. And obviously, like I mentioned, sorry, not here, because we're doing a test and we need to probably shave off 1 0 from here, because it's because we you know, we limited the emission area to a very small area as opposed to the whole thing. And to be fair, I think this will probably take a few additional work. So the other thing I was doing is that let's put a gas wrangle in case things fall down far too deep because we don't see them. I'm just saying, you know, if you go, if the voxel is less than -50, then density is 0 always. So it's going to kind of like do a little optimization. But also we did say this is the max BB, so that's gonna help, I guess. So the bottom is open, they're gonna disappear from the bottom, that's fine. Is it -50? Minimum is -207, so yeah, it's gonna disappear. Let's do as 100 anyway. Oops, not 10, 100. Okie dokie. And yeah, that's it. And plug the collider. Now what do we cache out? So again, for disk saving purposes, I'm gonna copy the elements from the other scene, so we can do that actually here. It's the smoke we want to just fetch because we have the output controls here. Simulation, no flames, source, export. I am not going to save the velocity. I'm not going to save the temperature. I'm not going to say any of these. And the reason I'm not going to say velocity is that I don't care about this slow moving volume velocity, to be honest. I did cache it out apparently before, but you know, it was slow moving. I don't have to do anything with it. So basically I don't have to do any post process, I guess. Yeah, so I don't need that. And doing a little bit more cleaning. So if I have a look here, something is coming up. The resolution needs to be set accordingly. So that's 0.5, which means 50 centimeters. So it's quite low res, but our scene is massive, right? So we need to just make sure that this is actually doing its job properly. So we should probably normalize. Yeah, so the edges are not harsh like that. Our pieces are not falling that fast, so this should do the job. The emission source velocity, I want to bring that down, definitely. Usually that causes me a lot of issues. Source density to 0.1 velocity, okay? Because it usually pushes the volume to front, and then it becomes somehow really dodgy. This should do the trick here. Of course, we need to cache that out as well. So here's our volume. Here's our particles. Here's our volume. Okay, and finally, I think I'm just gonna duplicate this. These can run in parallel. Just have to give them a name. Secondary. This can actually do that, and we can use the same with secondary source to shift the sources, but we need to make sure that we're not overriding. So secondary, you know, we should probably debris, give this a better name. Secondary debris sim, secondary smoke sim, so they don't override themselves, right? And if you want one to run after another, then you can give them a priority value. Where was this? So these are simulations, so make sure that this is on. You need to make sure that this is all frames in one batch, and they should have a priority value, or they had in the previous one maybe. No, they had in. They don't have anymore. Okay, they had a priority value you can put in. Maybe it's in the sugar. Oh, it's here. Okay, so you can change the priority here. Priority, so inherit from upstream, which means that if it's here, if it's plugged one before the other one, yes, one after another, or give themselves a priority. So if this was 0, then this one would be 1, but we can actually, you know, not to get the system tired, you can do this as well. Oops, actually maybe it's better because we're running it on one computer. So let's say do the particles, wait for all, then change length secondary, let's call this PTC or debris, and let's call this smoke. So again, like if our scheduler worked with a farm, you know, you could do these parallel, because the result of this doesn't affect this. But now to keep things a bit more safer, we're going to keep it separate. So it's gonna first for 500 frames for 4 wedges, 5 wedges is going to do the particles, then it's going to do the same thing for volumes. If you have like a Threadripper 3990, you know, you can probably do it a bit more, and as long as you have enough memory, should be fine. This structuring of this is completely up to you, basically, and to your hardware. And if you have a farm, you know, then that has a PDG schedule working, then it's amazing. You can just, you know, run them in parallel as much as you can. I think that's gonna be it. As soon as I plug in what this thing needs to simulate, which is out volume, and that should do. All right, so I'm going to stop the recording now for the video, for the volume, and actually cache this out. Only one wedge, because I already wedged the whole thing and previously, and everything is short on disk space. So I'm gonna reduce this to do only one wedge, which is 1. In this case, it will be cook selected 0, and then also this at 0, and I'm just gonna cache that out and see how it goes. All right, thank you for watching, and we'll see you in the next chapter.